Hey guys, welcome back to my channel. So today let's talk about 5 steps of doing hypothesis testing and 5 steps. And this could be the last episode of one sample test hypothesis. Okay, and at the end of the video, I also talk about the p-value, how to calculate p-value for one-tail and also for two-tail test. So this video I know is a little bit long, but I don't want to cut it into small pieces to destroy the completeness of this video. So I just want to present it as a whole to you. So hope you'll find this helpful and continuous and everything makes sense. Okay, without further ado, let's get into the video. Okay, let's talk about 5 steps to do hypothesis testing. Okay, here we're talking about one sample test of hypothesis. So we're talking about 5 steps. You can always follow these 5 steps to do hypothesis testing. So I'm going to use 2 examples. The first example is the case number 1, I just use a two-tail test. And case number 2, I use one-tail test. And step 1, you should know how to state the null and alternative hypotheses. So H sub null, H sub 1, right? So let's suppose I'm interested in whether population mean is different from 85. This is our old friend 85, right? Population mean equals 85. In the first episode of this hypothesis testing, I talked about the hypothesis, right? How do we state the hypothesis? And you can check out that video. Okay, so for case number 2, step number 1 is state the null and alternative hypothesis. And here, again, refer to the episode number 1, right? First episode of hypothesis testing. So we always put the research question in the alternative hypothesis. So if I'm interested in whether population mean or population mean score of statistics, the population mean is greater than 85, so I can just write mu greater than 85, mu less than or equal to 85. Again, so for hypothesis, we always put equal sign. In null hypothesis. Okay, and the alternative one is our research question, and hypothesis is a statement about a population parameter. Okay, so that's step number 1. Step number 2 is you should specify level of significance. In episode part 1 and part 2, I talked about significance level. I suppose here, by default, social science, significance level or level of significance or the probability of committing type 1 error is 5%. So here, step number 2, 5%. And step number 3, you should know this 5%. And step number 3, you should know two-tail or one-tail T or Z test. So in order to know the two-tail or one-tail, we talked about that in the episode number 2. You just need to look at this alternative hypothesis. If there's no direction, right, not equal to, no direction, there will be two-tail test. If there is a direction specified in alternative hypothesis greater than or less than, so there will be a one-tail test. Okay, so this one will be two-tail test. This is a two-tail test. And you should know is two-tail Z test or two-tail T test. Same thing. You should know step number 3. And this is one-tail because there's a direction specified in alternative hypothesis. So this one-tail test, and you should know that's Z test or T test. We talked about the T statistic and the T distribution in the previous video. Again, if and the sample size is large enough, or population standard deviation is known, we use Z test. If n is small sample, and population standard deviation is unknown, we use T test. Okay, same thing. N is large, or a sigma is known, we use Z test. If n is small and standard deviation, population standard deviation is unknown, we use T test. Okay, so Z or T test. So that's step number 3. Again, so here we can always use T test because when n approaches infinity, T approaches Z. So when n approaches infinity, the sample size is large enough, t approaches z. So that means when the sample size is small, you can use t. When the sample size is large, actually you can also use t. Okay, so when sample size is small, you use t. When sample is large, you can also use t. Okay, so that means you can always use t statistic, like do a t-test. This is step number 3. And step number 4 is formulate a decision rule. Okay, so that's formulate a decision rule. Okay, same thing. Step number 4, formulate a decision rule. Then can better understand by visualize the problem, right, by showing it graphically. Now let me show you the graph. Suppose population is normal distribution, okay, and the sample mean follows normal distribution, and we know this is population mean mu, and based on the null hypothesis, the population mean is 85. Let's assume population mean is 85. That means we assume the null hypothesis is correct. And we assume null hypothesis is correct. Same thing for case number 2. So this is x bar follows normal distribution, and mean of x bar is here. Let's assume population mean 85 is correct. So you see, that's why we need an equal sign here, because we need a value for the population mean. So we're testing null hypothesis. We're testing whether null hypothesis is correct. So we need a equal sign here. We need a value to plug into the formula. So we need a average of sample mean. Okay. Again, the null hypothesis is a hypothesis that is being tested. Okay. So now here, assuming null hypothesis is correct. So this is 85. And back to the case number 1. So we use a 5% significance level. So this is two-tail. That means two-tail test. That means I'm not only interested in whether population mean is greater than 85, but also interested in whether population mean is less than 85. So I just want to know whether population mean is different from 85. So now this 5% significance level is evenly distributed on two tails. Okay, so now here, which color is better? So this one. Okay, so this. Maybe this is 2.5%, 2.5%. Okay, so the 2.5% here, 2.5% here. In the previous 2 episodes, episode 2, part 1 and 2, the previous 2 videos, I talked very detailed about significance level. Why do we call this alpha level of significance or significance level? Okay, why this probability is also the probability of committing type 1 error. You can check out that video if you need to brush up that knowledge. So two-tail test, so 5% significance level evenly distributed on two tails. But one-tail test, and then you're only interested in whether population mean is greater than 85. So greater than 85. So now point to the right, and then there'll be here. Maybe this is a total 5%. You're not interested in at all whether population mean is less than 85, right? This is your research question. Check out the first episode of hypothesis testing. Okay, you're only interested in whether population mean is greater than 85. So your question is reflected in the alternative hypothesis. Okay, so this is a decision rule. So if the sample mean falls somewhere here, or somewhere here in this 2 yellow shaded area, and then you will say the difference between the sample mean and the hypothesized population mean is statistically significant. Or if the sample mean is somewhere here in this left shaded area, and then the difference between this sample mean and this hypothesized population mean is statistically significant. Or in other words, if the null hypothesis 85, if this is a true null hypothesis, is very unlikely, and fall in this 5% area, 5% probability, is very unlikely that you randomly select a sample and compute the sample mean this large or this small. In other words, you will reject the null hypothesis. And then this area will be do not reject the null hypothesis. And this 2 yellow shaded area will be rejection region, rejection area, rejection area. If this 2.5%, this 2.5%, suppose this is a large sample, you should know the corresponding z-value. Okay, right? So the corresponding z-value. So let me write here the corresponding z-value. This is the positive way to think about it. If the right-hand side, this probability, the area is 2.5%, what is the corresponding z-score? If the left-hand side 2.5%, pause this video to think about what the corresponding z-score. You should memorize this, okay? Because we use 5% very, very often, and very frequently, and especially social science. Okay, so if two-tailed test 5%, you should know this value is 1.96. I mean the z-score, right? This point, this value of x should be 1.96 standard deviations above the mean. And this point should be negative 1.96. That means this point of x bar, right, should be 1.96 standard deviations below the mean. Okay, and that's the decision rule. So now you formulate a decision rule as if the z-score for the computed sample mean, right, the absolute value is as extreme as or more extreme than this 1.96, and then you reject null hypothesis. Otherwise, you accept the null. So here you see this 1.96, 1.96. This 2 points actually is a dividing point, right? A dividing point between two areas. One area is you reject null hypothesis. Another area is you do not reject null hypothesis. Right? This is a kind of dividing point between the area you reject null and the area you do not reject null. And this is a dividing point between the area you reject null hypothesis and the area you do not reject null. So we call this 1.96, this corresponding z-score, critical value. So the z, this is called a critical value. So in this case, critical value is negative or positive 1.96, critical value. So the z-score for x bar is greater than critical value, and then you reject null. Okay, same thing here. So this is alpha, right? One tail, and this is a alpha over 2, and this is alpha over 2, right? So 5%, pause this video to think about what is corresponding value of x bar, right? What is the x bar that corresponding to 5% on the right tail? So 5%, it should be either 1.64 or 1.65. So this is a critical value, right? Critical value. So the decision rule will be, let's suppose there's a large sample. If the z-score for the corresponding value of x bar, okay, so now because it's only one tail, so the z-score for the corresponding x bar is as extreme as or more extreme than the critical value 1.64, we reject null hypothesis. Okay, otherwise, we accept null. So that this area is called do not reject. And the yellow shaded area is called rejection area or rejection region. And this the very, very important, the most important step, is formulate the decision rule. And then the last step, let me just move up a little bit. So step number 5, the last step, is use the sample data to arrive at the decision. Step number 5, use the sample data to arrive at decision. It's only in the last step should you use the sample data, right? If the sample data getting involved. So let's suppose this n is 36. Out of population, you take 36 number of observations, and you compute the sample mean, maybe is 90, and you compute the sample standard deviation, maybe is 6. Okay, and then this is your sample data. You should know that in practice, you always know the number of observations in your spreadsheet. You always know how many observations you have, and you can always compute the sample mean and the sample standard deviation. So now you know the value of x bar is 90, but you should know is 90 more extreme than 1.96 standard deviation above the mean, or less extreme than 1.96 standard deviation is above the mean, right? So And what you could do is you convert x bar into a z-score. So the z-score for x bar equals a value of x bar minus the average of x bar divided by standard error of x bar, right? Central limit theorem. Value x bar is 90. Average of x bar, that's why we need to assume the null hypothesis is true, so it's 85. And the standard error of x bar, large samples, that equals the sample standard deviation divided by square root of n, right? So then you solve this 5 over 1 is 5. So that means this 90, the sample mean 90 is 5 standard deviations above the mean. So which is more extreme than 1.96 standard deviation above the mean, or maybe 5 standard deviations somewhere here. So this is a 90. So that means if the null hypothesis is true, that means if the population mean is really 85, it's only less than 2.5% chance. It's a very little probability that you get a sample mean 90 or even more extreme than 90. And because this is greater than 1.96, so we reject null hypothesis. Okay, so that's the conclusion of case number 1. I just write this way. And for this case number 2, one-tailed test, right? I need to get the sample data, arrive at decision. So let's suppose I have the same data. Number of observations x bar is 90 and the sample standard deviation is 6. And then I need to convert, next step is I need to convert x bar into a z-score. So there'll be 90 minus average of x bar, which is 85, hypothesized population mean, and divided by sample standard deviation over square root of n. So I have this 5 over 1 is a 5, which is greater than 1.64, right? Which is greater than 1.64, which is critical value. And then so we reject null hypothesis. Again, that means if this is a true null hypothesis, if the population mean is 85 and it's very, very unlikely, less than 5% chance, the 5% where it's coming from is coming from the significance level, right? This is the standard criterion, standard. So if this is a true population mean, it's just a less than 5% chance, you get a sample mean, you randomly select sample and get a sample mean 90. Okay, it's very small because 90 is falling this rejection area. Maybe 90 is somewhere here, right? Maybe 90 is here. Okay, this is 5-step procedure of doing hypothesis testing. So again, in this case, we are using this way, right? We're using this decision rule to figure out whether to reject or accept the null hypothesis. Another way you could do is you can calculate p-value. So I better briefly talk about p-value here. Okay, so now just look at the two graphs, and then the next point will be p-value. P-value is based on the sample statistic. Right? P-value is based on the sample statistic. Is based on this. So p-value is based on the sample data. So p-value, right? Use this data, we can solve for the p-value. So p-value based on sample data. The p-value is, in this case, two-tailed test. P-value just equals, right? The p-value equals, because two-tailed, so graphically that this area, use the sample data 90. The probability x bar equals 90 and more extreme than 90. This red area, this red area times 2. So that's p-value. So in the equation, in the form of equation, the p-value equals 2 times probability that x bar is as extreme as or more extreme than computed x bar 90. Right, so you know x bar follows normal distribution. You know the hypothesis population mean is 85. So you know everything. Okay, so x bar average 85 and standard error of x bar equals 6 over square root of n. So you know mean and you know standard error, and you know the value of x bar somewhere here, 90. And then you can easily calculate the probability that x bar greater than 90. Okay? And then you can easily times 2 to get this p-value. Okay, the p-value is assuming the null hypothesis is true, because we need a value to plug into our formula. Assuming the null hypothesis is true, and the probability that you compute the sample mean that is as extreme as or more extreme than the computed sample mean, in this case is 90. Okay, so this is p-value. So for one-tailed test, the p-value is graphically is just this area. Okay, so this x bar, value of x bar 90, so this is the p-value, this area. You don't need to multiply that by 2 because this is one tail. So in terms of equation, so in this case, p-value equals probability, don't need to multiply that by 2, x bar as extreme as or more extreme than 90. And you know x bar follows normal distribution, assuming the null hypothesis is true. So you can write 85 here, and you observe 90. And then this is the p-value, which is the probability. Okay, so you see you can always compare p-value with alpha. Alpha only depends on, okay, let me write here. So alpha, it depends, is 5% right here. We pre-specify the level of significance, which has nothing to do, this 5%, right? So which has nothing to do with the sample data, right? 5% is just your selected level of significance. In this case, alpha is 5%. So in order to make decision, in order to make conclusion, whether to reject the null hypothesis, you can just compare this two value. One is p-value and the other is alpha. They're comparable. So p-value, so this add up this two red area. The p-value, apparently in this case, add up this two yellow area, 5% is alpha, right? And this two red area add up together, you get p. So p-value is less than 5%, we reject null. Okay, so let me write here. So p-value, if the p-value less than significance level or equal to, because we really want to reject null. Okay, you will know that most of the time we want to reject null hypothesis, so we reject null hypothesis. Otherwise, we accept null. Okay, because most of the time we want to reject null hypothesis, so you always want to have a small p-value. So I can write it this way. So the lower the p, the better. So the lower the p, the better. The lower the p, the better chance we reject null hypothesis. Right, same thing here. So p-value, same thing for this case, right? So p-value, this red area, right? This red area, p-value, this probability that x bar more extreme than 90. And this yellow area is just a 5% significance level. So now you can write this way, right? So in this case, p-value less than 5%, which is alpha. And then or equal to if this decision rule, right? And then we reject null hypothesis. So in this case, that's true, right? So we reject null. So the lower the p, the better chance we reject null hypothesis. The lower the p, the better chance we reject null hypothesis. So in order to reject null, we either want to have a greater value of z score or t score, or to have a smaller value of p-value. Okay, again, to reject null hypothesis, we would want either to have a very large z-score or t-score, or to have a very, very small p-value, the p-value should be less than 5% significance level. The reason you times 2, because this is two-tail, and also more importantly, you want to compare p-value to alpha. Right? Only you times 2, and you can make these two things comparable, right? You can compare these two values. Otherwise, just compare to 2.5%, right? Yeah, so this is 5 steps to do hypothesis testing. Hope you find this helpful. 5 steps to do one sample test hypothesis, okay? Case number 1, case number 2, 2 tail, 1 tail, 5 steps. State the null alternative hypotheses and pre-specify significance level. You should determine is it 1 tail, 2 tail, 0 or t-test, and formulate the decision rule. You can use a critical value or you can use the p-value, right, to formulate the decision rule. And then the last step, using the sample data, arrive at decision. You would want to have a larger test statistic in order to reject null, or to have a very small p-value. The smaller the p, the more extreme that sample mean is, right? And the more likely you reject null hypothesis. Yeah, hope you find today's video helpful, and any questions, let me know. Hey guys, hope you find today's video helpful, and this is a 1 sample test hypothesis. And for 2 sample test hypotheses, we can also follow these 5 steps, but the thing is there might be many different situations. For example, 2 large samples and the samples are dependent of each other or related to each other, or there's 1 large sample, 1 small sample, they're independent of each other. So how to do the test hypothesis? And these are on my list, okay? And for any other questions, comments, please let me know. And thank you so much for watching, and see you next time.